Hey you guys, this is Mr. Millings and welcome to part 1 of a 6-part series on challenging mole conversion problems involving density and shapes. And in part 1, we are going to apply mole conversions to spheres. So let's jump right in and take a look at an example. In this first example, it says a gold sphere has a radius of 5.15 centimeters. Calculate the number of atoms that make up the sphere, and we have to round our answer to 3 significant figures. So if we take a look at this word problem here, we have a gold sphere, and it might be a good idea to make yourself a little drawing like I'm about to do. So we have a gold sphere. We know that this is gold, or AU, and secondly, what we know about this sphere is that its radius is equal to 5.15 centimeters. And so what we're trying to figure out here is how many atoms this gold sphere is made up of. So we want to know the number of atoms of gold that are in this gold sphere if its radius is 5.15 centimeters. So how are we going to do this problem? Well, let's think about this. We know that the sphere is made of gold and we know its radius. So what we can probably figure out first about this sphere is its volume. So we can figure out the volume of a sphere using this formula right here, the volume of a sphere formula, and you can Google this information, but the volume of a sphere is going to be equal to 4/3 pi times r cubed. And so if we first figure out the volume of a sphere, what we can then do in step 2 is we can then calculate the density of the sphere. Right? Density is equal to mass over volume, and we learned this in an earlier video. So once we figure out the volume of a sphere, we can then plug that into our density formula right here, and we can solve for the mass of the sphere. And last, what we can end up doing is once we know the mass, we can run it through our mole conversion right here. So in our third step, we're going to do some mole conversion. So hopefully that makes sense. We know the radius, we know this is made out of gold, so what we can do is calculate the volume of this sphere using this formula here. Once we get the volume, we're going to plug it into the density formula and solve for the mass. And once we figure out the mass, we can then figure out the number of atoms by running it through this process right here. So let's go ahead and start with this very first step. In the very first step, the volume of this sphere here is going to be equal to 4/3 pi times r cubed. So we have 4/3 pi times r, which the radius here tells us is 5.15 centimeters. 5.15 centimeters. And what we're going to do is we're going to cube this. And so when we put this in our calculator, we're going to end up with a volume of 572 cubic centimeters. So here is our volume. So now we know the volume of this gold sphere. In step 2, we'll do step 2 right here. Let's go ahead and use the density formula. We know density is equal to mass divided by volume. We know the volume, it's right here. And if we take a look at some sort of density table, we can figure out the density of gold. And so if you take a look at the density table that just popped up, you will see that gold has a density of 19.300 grams per cubic centimeter. So what we can do now is we can figure out the mass, right? So if we know that density equals mass divided by volume, and we want to figure out the mass, we'll multiply both sides by V here. V is going to cancel. So to get the mass of this gold, we'll simply take the volume and multiply it by its density. So what is the volume of this cube? Well, we just figured that out over here. It's 572 cubic centimeters. What is the density of this cube? It's right here. It's 19.300 grams per cubic centimeter. And so the mass of this cube is going to end up being 11,040 grams. And if we want to convert this to scientific notation, this will end up being 1.10 times 10 to the fourth grams. So here is our mass of this gold sphere. So now that we know the mass, in step 3, what we can now do is we know the mass in grams. It's right here. So we can run it through the mole conversion process to figure out the number of atoms. So let's go ahead and do that. In number 3, we know the mass of this gold sphere here. We just figured it out. It's 1.10 times 10 to the fourth grams of gold. And what we want to do here is we want to figure out the number of atoms. So we want to cancel out grams of gold. We'll put that at the bottom. And we're going to convert this to moles of gold first. We'll put that at the top. Once we're done doing this, we want to cancel out moles of gold. So we'll put that at the bottom. And we're going to want to convert to atoms of gold. So we'll put that at the top. So now, what is the relationship here between moles and grams of gold? Well, if you look at the periodic table of elements, like the one that just popped up, you can see that the molar mass of gold is 196.97. That means for every 1 mole of gold, it's going to have a mass of 196.97 grams. And so now, what do? Well, we just figured out the number of moles by dividing by the molar mass. Since this number is in the denominator, we're going to take this and divide by it. And now we need to figure out the number of atoms. So now we have to multiply by Avogadro's number. We know that 1 mole is 6.02 times 10 to the 23rd atoms. And so if we take a look, we have grams in the numerator and grams in the denominator. They can cancel. Moles of gold in the numerator, moles of gold in the denominator, leaving us with, we'll go ahead and just put this right here, atoms of gold as our unit, which is what we were trying to figure out. So now let's go ahead and put this in our calculator. We'll take 1.10 times 10 to the fourth. We're going to divide this by 196.97. And then we're going to multiply this by Avogadro's number. And we should end up with 3.36 times 10 to the 25th atoms of gold. So this here is going to be our final answer. So if we have a gold sphere here and its radius is 5.15 centimeters, how many atoms does this gold sphere represent? 3.36 times 10 to the 25th atoms. So that's how we're going to do that. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that's going to subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.